Good afternoon, everyone, and thank you for attending this breakout session. My name's Nathan Green. I'm the Worldwide Data Architecture Leader for Teradata, and I'll be moderating this session for you today, along with Jim Bagartsius here. There'll be time for question and answer at the end of the content, so if you've got a question, please just raise up your hand. We'll come over with a handheld mic and you can ask away. So today we're going to be hearing from Gary Klass and Bob Fintel on the importance of using AI or agentic-ready data products to support and develop customer intelligence solutions. So with that, please join me in welcoming Gary Klass up to the stage. Thank you.
All right, can you hear me? Yeah. Okay, very good. So thanks for coming today. Thanks for skipping lunch to come see us. Nah, lunch will be later. So here's our agenda for today. We're going to talk about the Customer Intelligence Data Foundation, kind of what we mean about it, industry knowledge, data models and product details about those, and then finally, Teradata Customer Intelligence Data Products, Enablers, and Benefits. And once again, I'm Gary Klass. I'm the Global Financial Strategist for financial services, and obviously Bob will be following me. So again, thanks for coming. So kind of set up this framework before. It was a little bit introduced today during the keynote. It's really about this idea of the customer intelligence framework. And here we're going to talk about customer intelligence activation in banking. It has 5 steps. The first step is converting the data and processing the data to generate a signal. And that requires the second step, was a signal-driven business architecture. Third key component of this is data products at the core, the importance of data product in the customer intelligence framework. I'm going to focus on that. And then once the data product is available, applications, the application at scale, and then finally the benefit and the application in financial services. So let's talk about data products at the core, and let's kind of define what we mean by a data product. So data product is reusable. It generates AI-ready signals that drive real-time decisions, embedding intelligence into customer-facing applications. So another way to think about it is you basically organize your data to be ready to use to support multiple use cases through the data product, and you basically want to evaluate that and has a framework that delivers the signals that can be acted upon in downstream applications, of which there are quite a number. You can think about marketing applications or fraud applications or next best product applications. So data products again, in this context, we want to leverage Teradata's pre-built industry data model. It's an excellent financial services data model that's very detailed and been developed for 20, 25 years at least. Leveraging structured data that's scalable and really focusing on this idea of a customer 360 schema, which is basically what's all the full dimension of attributes you want to know about your customer if you're a bank. That connects the customer dimension, resolving to customer identity, what products the customer has, what channels they use, what are they doing in the channels, how do customers change through time, and this idea of a network dimension, which is what's the social network that the customer exists in. Data products organize multi-dimensional customer data into a structured data frame, and again creates this reusable data product that supports models, scalable models that can be executed across all the different dimensions of customer activity. So if we have the customer 360 schema set up appropriately, we can think about all the different dimensions of the customers I described. And then basically, once you develop these data products in one area, there's a synergistic effect as you develop other data products and you learn more and more about your customer. Things that you can learn about your customer in terms of channel activity could be important in marketing, could be just as important in fraud analytics. So data products are curated collections of productized data sets, productized meaning they're repeatable and at scale, and this idea of enriching them with business-approved metadata. So we all know what metadata is. Business-approved in this context is people in the line of business or that are experts in the data that use the data, understand the data dimensions and agree how the data is modeled into these data products. And again, once you've invested in development of data products, then you can use them for multiple use cases. And I'm going to give you some illustrations in a bit. And I'd like to talk about it this way, that data products are a capital good, just like a factory or just like a tractor on a farm. And we're going to transform data assets into applications that generate immediate and long-term business value. I'm going to talk to you about data products that we are going to feature for financial services. Before I came to Teradata, I worked for Wells Fargo Bank for 34 years. And there's stuff that I created that were instantiated as data products that live on today, and they've been generating value for 25, 30 years. So once you invest in it and do it appropriately, it is a capital good. It will generate benefits for a very long period of time. So what are some examples of a data product? You probably have heard about this before. You heard about it earlier today. This is customer complaint analytics. Customer complaints, every business has to deal with customer complaints, and it's challenging for every business. But in regulated industries like banking, it's very important because banks are accountable to their regulator in terms of identifying and dealing with customer complaints. But it can be very tough if you're a bank to identify the complaint. People can write you a letter, they can send you an email. But most customer complaints are logged in an inbound phone call, which is very difficult data to deal with because it's unstructured data. So many customer complaints are buried in these unstructured data interactions. So the Teradata solution is to leverage state-of-the-art language models to interrogate those inbound customer communications and assess the nature of the complaint, as well as the customer sentiment. Are they a little bit angry or very angry? Generally, they're not super happy if they have a complaint. And a lot of the benefit of interrogating those complaints, the unstructured data with language models, is that you can take the distillation of the insight from that, what the topic is, what I like to call customer task, what is the thing that the customer is trying to resolve, the sentiment, how unhappy are they, the specific topics that they're talking about, and you can append that on to the already existing customer schema that you have that leverages the structured data across product, channel, and other dimensions. So we can think about this as a three-part process. The first part is discover. We want to analyze those verbatim complaints. Again, most often this occurs in speech and text. We want to predict in the sense that we want to identify the topic of the complaint and the severity of the complaint. Somebody complaining about that they didn't get their statement on time is very different from, hey, I think somebody took my card and I don't understand this payment for $500. And that's really the goal of that, is to anticipate these issues by leveraging large language models to identify the customer task, once again, the thing that the customer is trying to accomplish to reach their financial goal that underlies the complaint. And the third step is intervention. Once we've identified the complaint, of course, we at the bank, we want to resolve it as efficiently as possible. And we want to support the response of the bank, usually customer service agent, maybe in a branch or on a call center, and give them a set of information and tools that they can use to respond to the customer and resolve the complaint. So what are the benefits? And by investing and supporting the customer complaint analytics data product, decrease the cost of responding to complaints. Eventually, you reduce the number of complaints, which can be very painful if they're escalated to regulators, because there are actually financial penalties that can be assessed for non-compliance of complaint resolution. And by far, the most important thing to think about if you really invest in complaint analytics is, for every person in a bank or every customer that takes the time to complain about something, there are 10 times as many customers that had the exact same experience and never took the time to formally complain. So once you focus on complaints, it's really a tip of the iceberg problem. The tip is the complaints that you see and are formally made and you analyze, and the iceberg is all the other people that had the same experience, but again, didn't take the time to complain. So very important to resolve it. And if you're a bank and you want to get to a point where you have less complaints and the complaints are less severe, you need to invest in this entire process of discover, predict, and intervene. Another data product, one of my favorites, I spent a long time in banking working on this, is customer journey analytics. There are many channels. There's a proliferation of channels, the traditional ones of branch, ATM, phone agent, of course, mobile, digital, and customers, you choose to use them in various forms. Oftentimes, customers have an issue. They'll start in one channel and they'll migrate to another channel. So they use channels, again, either in sequence, sometimes in parallel. We found out by doing customer journey analytics at the bank that 2/3 of the time when customers were speaking to a phone agent, that customer was currently in or had been in their mobile banking application. So there's a lot of parallel activity that happens in channels. It's very hard to see if you don't collect and integrate the data. So the business problem is you really want to be able to measure the bank's ability to effectively resolve customer tasks. The problem that the customer has today, and that helps you to maximize customer engagement. And if you do it, invest in this process, it'll become a very efficient process to resolve customer tasks, and that minimizes cost. So a lot of times this is described as channel friction. You want to make it so the information passes seamlessly across channels, and that anybody involved or any channel involved in the process is a holistic view of what the customer is trying to accomplish, their customer task. So Discover, key activity there is to harmonize all the channel interactions data, define the common customer key that's in all those different channel sources, and they're all their own little silos. You usually want to resolve to a customer number, and you want to sequence that channel activity by time. And I can tell you that Teradata's wonderful technology can support that. We use this thing that you can find in ClearScape. It's called NPath, which you can sequence any data at scale. And I like to say that NPath is the sixth wonder of the world because it's just an amazing piece of technology. You can take any of that channel data, if it has a timestamp, and sequence it. And we could do that exhaustively when I worked at the bank. So the first step is to analyze those customers and sequence them using NPath. The next part is to really predict, which is really assigning what is the customer task that the customer is trying to accomplish in that journey. Do they want to add another person to their account? Do they want to get a fee resolved? Maybe they're interested and the bank could offer a mortgage. The sooner the bank can identify the customer task, the more effectively the bank can resolve it. So everything is about processing all that data to identify and label the interactions with the customer task. And that customer task, of course, is a signal of customer intent. You can anticipate and understand what it is that the customer wants to do. And the third part here is to intervene. There's this concept of a normative path. The bank has designed a process that it would like for its customers to follow. There's a way to go about adding another person to your account, and banks are very much into process and they want you to do it a certain way. So what we want to do is organize and analyze this customer activity to see if the customer is following the normative path or if they have fallen off the normative path, off in the weeds, down in the gutter. We want to get them back onto the normative path to resolution. So what are the benefits of the data product customer journey analytics? So you can now identify that customer task efficiently. You can figure out, well, what is the impact of failing to resolve that customer task on important things like customer retention or the value of the customer. Customers use every interaction with the bank in a sense to assess whether or not they want to stay with the bank or maybe think for an alternative. Again, we talked about complaints. Customer journey analytics is generally a very important component of customer complaint resolution and mitigation. And then a really side benefit that was kind of an unintended benefit, but ended up being really valuable was if you invest in this and you collect everything down to the second, you can actually cost it out within the channel and you can get an exhaustive and accurate cost to serve for every of these customer channel interactions, which for most retail customers, it's actually what determines whether they are slightly unprofitable or profitable. So it's a super important activity for any bank to engage in. So the next data product I'll talk about is one of my favorite things, customer lifetime value. So this is the basic idea that customers, the bank can assess today what their profitability is, but what's really important is what the expected value or profitability of that customer is over time. And to do that, of course, you have to assess current period profitability, but you actually have to have a very robust model of the likelihood that customer will stay with you, basically a model of attrition. And it's very valuable to invest in that. So the business problem is banks often don't have a good idea of what the current period value is. Most banks really don't have any idea what the potential future value is. And that's very important because you want to assign the resources that the bank is allocating to that customer based upon their current and potential value of customer lifetime value. So you're able to, with the data product, customer lifetime value, address that problem. Using the financial services data model I described, carefully go through, be able to calculate the account profitability, the channel activity, the cost of that, roll it up to the customer, and then use a family of models to identify what's the likelihood the customer will stay, what's the likelihood the customer will buy some other product. These things are all related and can be modeled very efficiently. So the first thing we want to do is discover the drivers of customer retention and profitability. It's somewhat of an accounting exercise, but it's also a modeling exercise. And most importantly, identify what are the levers, what are the attributes that may make a customer more likely to stay, things that are sticky. For example, payments behavior is a very sticky thing. One of the things that we discovered was allowing our customers to schedule paying their bills online. Super sticky activity because it's a recurring behavior. It's very important to them to pay their utility bill. So that's a great example of something that we discovered in the modeling of customer retention that's valuable. Prediction, of course, is of customer attrition as I described, but it's also of customer lifetime value. And it's really about what are the levers that you can address if you're a bank in terms of your strategy, your servicing model, and of course down to the individual customer, and that's the intervention part. You may have heard of this concept of next best action. Really what you're trying to do, if you want to be optimally efficient if you're a bank, is having this framework of customer lifetime value available for every customer. You want to figure out what is the next best thing that I can do to promote that customer realizing that value, which is often what can I do today to get that customer to stay. It could be resolving an unresolved customer task. It could be telling them about a feature they weren't aware of. It could be oftentimes supporting their acquiring another product. And you really can get to a high level of precision and really almost optimize how you communicate with customers to maximize customer lifetime value. The benefits, one of the things I found in working at the bank was very focused on acquisition. Let's get more accounts, let's open more accounts, let's spend a lot of money, let's advertise on the Super Bowl. And so tremendous marketing allocation to acquiring new customers, while at the same time, a lot of existing customers were eroding away. And we were finally able to use this customer lifetime value framework to say, hey, let's think about investing in customer retention. That oftentimes has a better payback than actually investing in customer acquisition. And the customer lifetime value framework is a way that you can really assess those trade-offs. And one way I used to characterize it pretty often was, what's the value if the bank could increase the customer attrition by 1%? Really big number. What if you could reduce customer attrition by 0.1%? Also ends up being a pretty big number. And investing in a data product like customer lifetime value gives you a lot of authority to understand that impact. So those are the 3 data products that we've developed that are available today. There are a bunch more that are on the horizon. I'll briefly go through them. Financial crime, which is a regulatory related activity. Know your customer, anti-money laundering, suspicious transactions monitoring, all very important, all very consume a lot of data, and that data needs to be modeled and understood. That's what the data product addresses. Payments fraud risk, what data do you need to collect and organize to understand the riskiness of any given payment activity? I like to call it Payments 360, which is the idea of integrating and normalizing all the payments data, which I did at the bank I worked at. A very unusual thing to do, but it's pretty fascinating. It answers the question, a customer's got to pay $40 for pizza. How do they decide to pay it? Do they use your credit card? Do they use a debit card? Do they use PayPal? Use cash? Understanding that actually is way more important than people think it is because it has a big impact on customer loyalty as well as direct revenue. Things that are probably pretty obvious banks should be focused on, like consumer credit risk. What are all the different dimensions that you should understand about whether a customer is likely to repay a certain financial obligation? Sometimes they don't pay. you back, but you want to try to convince them to. That's customer repayment and collections. And a great illustration of the application of customer journey analytics is actually in collections, is understanding where that customer is if they're interacting with the bank, so you can find where they are so you can talk to them. Commercial credit risk, it's a little bit different than consumer credit risk. It's a lot more about collateral. What are the assets of the business entity or the real estate assets? I talked briefly about new customer acquisition. Banking is very different from a lot of other industries. Selling somebody or opening an account is not the end game. The end game in banking is to get that customer to use that account in a way that generates value over time. Many accounts are opened in banking that actually lose money. Personalized offers, we talked briefly about next best action. There's a set of constellation of data that we can use to organize and identify what's the best way to facilitate a direct offer to a customer. And then finally, the whole area of investments. A big one is asset allocation, which touches upon many areas of investment, including wealth management. So with that, I got one more, sorry. So this is really kind of illustrates, again, the idea of using the data products, leveraging the data model to transform signals into action with multidimensional data. And you can see we give you some representative illustration of the type of data, how you organize it, and the data products I had talked about, complaints, customer attrition, lifetime value, customer journey, with the goal being to identify and distill signals that can then be populated to downstream applications and being worked upon, whether it's the agent in a contact center, or it's outbound marketing, or it's fraud mitigation. So there's multiple applications of these data products. And with that, I will turn it over to my esteemed colleague, Bob Fintel.
All right. Thank you, Gary. Thanks. So, again, my name is Bob Fintel, field CTO with Teradata, but a recovering data junkie. That's who I am, because I've basically done data for the last 25 years across many different industries. And I'm really excited in supporting Gary's efforts, Finian's in the back of the room, Nathan Green's team that's actually doing a lot of the heavy lifting on this effort to start mapping and really building a solid foundation around data product definitions to support agentic AI within financial services and other industries as well. So what I'm going to go through real quick is some of those modeling foundations that are actually going to be really important to deliver it in an agentic AI environment. So the first one is, how complete is your data definitions, right? Is, you want to accelerate customer intelligence, but you don't want to spend a lot of time necessarily doing modeling, data modeling. So we're providing some reference templates to get you started pretty quickly based on experience and based on the deep knowledge that's captured within our industry data models, which I'll show in a little bit. The big thing on this is, for agentic AI, what is AI-ready data, right? And we talked about that this morning in the keynotes. And to me, a big part of that definition of AI-ready data is, how well does the data that you're feeding into AI represent the business, right? So that third bullet down on the left is, does it fully represent the business's data needed for your agentic processing? And that's extremely important. And so the reason why are we doing the mapping back into the industry data model? Because the industry's data model is a complete data representation of a financial institution. Just like the transportation model is a complete representation of the transportation transportation industry, or telecommunications, or retail, right? So it's a data representation that tells you a level of completeness of a data definition of that business, depth and breadth, right? And so you want that depth and breadth to feed your agentic AI processing to the extent that it can, to get the best results. If it has to fill in gaps, right, we know it will start to hallucinate. It won't be as accurate. The agent won't execute efficiently because it doesn't have that representation. That's why we're doing the mapping back to the data models. We're not doing it just for a data model exercise, right? Been there, done that. We're doing it because we're leveraging the knowledge captured in the data model to represent that data to feed agentic AI at a very high level. So that's the really big thing. And then our reference templates on the last bullet is, move quicker from what data is required to activating data with derived signals for agentic AI, right? So I'm going to go into, in my part, I'm going to go into some of those hooks, if you will, into the data models that we have. Just explain that and show you that hopefully some of the advantage of that. So just at a high level, right? So there's, in this case, financial services data model. The FSDM is on the left-hand side. We'll get into some stats around it here in a little bit. That is the business data representation of a financial services institution, right? And so that's actually very complete. There's over 4,000 entities in it. It covers all the lines of businesses within a financial institution. The analytic schemas are more application specific. So we're bringing that generalized business data closer to a specific application. And we do this around these data product definitions. And we'll show you a couple examples of those in a little bit. So we're using these analytic schemas to make the model more application specific, but even the analytic schemas are mapped back to the FSDM and the depth there. The other reason we're doing it is there's a complete this is actually in a way bringing data models back to life, right? So for an analytics, how many data scientists really care about the underlying data model? Like hardly at all, right? Just being truthful, right? They care that the data is good, but they don't necessarily care about the data modeling. They care about the analytic modeling, right? And that's been the case. But what we can do is provide the data model foundation to them, right? And bring the agentic processing, the conversation around the agent to life using the depth and breadth of the definitions in the data model, right? So if we put this through, and we're working towards this, if we put the 4,000 pages, it's not that big, but 500 pages of data dictionary that defines the FSDM through a language model, now I have a capability to have a conversation with the model behind the scenes, right, as part of the agent. So the depth and breadth of these definitions is extremely important. In the past, the person that could do that was really the model creator. Her name is Nancy, by the way, and she retired a few years ago. We want to bring kind of Nancy back to life to be able to have an agentic conversation with the data model, given all the depth and breadth within it. That's the other reason we're doing the mapping, right? And so that's really complete. And I wish I had a printout of it. Printouts are so old-fashioned, but it would show you the depth of that model that we're drawing from, right? And so there's a little framework that we've set up. Again, this was from Nathan Green's data architecture team has been doing this. And so what is this data product framework that we're building, right? And so it basically takes that financial services data model, the major entities and data domains within there, mapping into some functional views. In this case, customer, CRM functional view. Those existed in the model for years, right? Around customer journey, around customer lifetime value, et cetera, but they weren't necessarily discrete data products to feed an AI agentic application, right? So we create different data products along the way. And then what we're doing is for these specific applications, working more right to left rather than left to right, source to target. We're working what is the problem we're trying to solve, customer lifetime value, back into the model. What are the end data products that we are trying to define and kind of meet it halfway, right? Make it much more usage driven from an application perspective, right? And so the end data products, what we're going to see on the bottom is actually what's really important, right? It gives us a really good definition of what data do I need to give a complete representation of a customer from a customer journey perspective, right? And have very detailed data definitions behind it to feed the AI agentic conversation that we want to have, right? Going forward. That's again why we're doing this work behind the scenes. And then at the end of the day, to save everyone's time with reference models to start this process and get into, I have that data in Teradata, I have it in my data lake, I have it on this other system, and start bringing that data together to drive these agents that we are trying to do as part of what we're doing in the agentic AI world. So these are all the different data categories. Again, as representation of what's in the FSDM, customer profile, product credit, all those standard things, but they're very detailed at a very detailed level within the model, right? And the mappings that we're doing between these data products to match the functionality, the capabilities that we want to deliver through the generative AI processing that we're doing, that's the data foundation to it, right? So a little bit of stats around the model, and I'm not here to sell the model. I'm trying to sell the value of why you want to start with one, right? Is the depth and breadth, again, of that business representation of data, and that, generative AI and agentic AI can actually deal with the volume of information and knowledge captured within that model, and we want to take advantage of it. So there are in the current version, 1703, 10 major subject areas. Those are the subject areas listed, right? Over 4,000 entities, over 17,000 attributes of a financial services institution, right? And it's a complete definition of it. And so we're drawing from that knowledge base. We've actually started using the term industry knowledge models, not just data models, right? Because we're going to create knowledge from that in context of an agent executing against that data. That's what we're doing, right? So we're doing that transition. But there's no reason to recreate the wheel. We've had this and built on this for the last 25 years, based on real customer implementations through those 25 years. So that's why we're leveraging it. So here's a sample. I should probably have Gary come back up and walk through this, but we'll just kind of go through what is some of the key relationships and elements here. And it's really, I just want to show an example of the reality of the work that's being done behind the scenes to do this mapping. And so this provides, with Gary's help and others, right? And the other thing is, this isn't just a modeling exercise. We're taking this through with our data scientists on the team and building what I call soup to nuts, from mapping and starting building agents and starting building, generative AI capability mapped to this, right? So this isn't just a modeling exercise. It is actually a full end-to-end delivery of this capability, making sure that these data product definitions actually match what a data scientist needs, what a modeler needs to, an analytic modeler needs to deliver the agents that they want to do, support, in this case, customer lifetime value types of conversations, right? So this isn't just some modeling exercise. This is really binding to that data layer bound to the application layer within that agentic AI framework. So customer lifetime value contains forecasted profit contribution, all these relationships, and it's really important. The relationships are important as much as the base data definitions within these models, right? And so because that helps in the traversal and the connections that generative AI that agents will be able to make between conversations and the response back to the customer, the response back to some chatbot or whatever the application is, right? So it isn't just the actual attributes, it's those relationships that have semantic meaning within the context of customer lifetime value, which is really important, right? So let's talk a little bit about how Teradata contributes to this. So the first thing is, we're leveraging these industry models for that, but if we bring MCP agents against this, as I mentioned earlier, we can start having conversations with these agents with all the base and knowledge that's being brought in from the data models and the analytic schemas, right? So MCP-based processing leverages encapsulated knowledge that we put through the large language models, right? Establish a vector-based knowledge asset that actually brings that data knowledge to life within that execution. Enable natural language access to the knowledge captured within the model, and then facilitate reuse of data products and derived features via an MCP-based agent, right? So in a way, how many people in this room are looking at data catalogs within your organization? Data catalogs are going to change dramatically. And the reason is they are the houser of the metadata within the environment. But if you take this through MCP, I can actually start browsing and finding data through these agents along with, or aside of a data catalog, right? I can browse, I can question, I can find elements of what I'm trying to find as a data scientist or as a data analyst, and I don't necessarily have to go through the data catalog user interface every time to find it, right? So the world of data cataloging, the metadata is still the case, is still highly needed. The interface is now changing, right? From an agentic AI perspective. So that's something that's actually going to be happening with the onset of MCP agents, to go at and help me browse my data products, browse the data within my environment, et cetera, based on the metadata that's been captured. So this is actually a start of a shift, I think, that's going to happen in the industry over the next couple of years. And as we talked about this morning in the keynotes, this happens fast, right? So I already know that data catalog providers are starting to pick up on this, right? And they have to provide that level of capability through their tools as well, right? We'll see what method works best as we move forward, right? So Steve McMillan showed this customer intelligence framework on the stage this morning, and the team, Gary's team, has helped build this, right? And we've actually done mapping to more technical architecture behind the scenes. But this is a data product conversation, so I wanted to focus on number 1, 2, and 3 around where these data products plug into within the customer intelligence framework, right? So number 1 is the multidimensional data products. Again, you've got all this different data sitting in the system, and it's used for source once, use many, right? And so we want to drive it to customer lifetime value, customer complaint analytics, right? Customer retention, customer attrition, all these different data products that get and try to drive out value from an agentic AI environment, right? And so we're bringing in this multidimensional data in real time within the platform, and Teradata just deals with it, right? These can't be fixed canned queries. They cannot, right? Because the situation with the agents are going to constantly be changing. The conversation, the situation is going to constantly change. If your data is static, your agents are going to be static, right? So why do I say that? That's what Teradata excels at, is ad hoc queries. Say even I'm having a business analyst and they're having a conversation. They might basically give me all the tables related to customer lifetime value, right? And then join those tables. That could be a 75-way table join. Seriously, right? Ad hoc queries, the user doesn't know, right? The system has to deal with it. Teradata deals with that. We have customers that are commonly doing 150-way, 200-way table joins. I won't get into the reason why they have to do that in certain banks, and the system just deals with it. There's no query limits within Teradata. It's formed in spool, it's dynamic, right? The result set is based on the query, not based on some canned structure of data, right? That will not work in an agentic AI environment. So that multidimensional data product has to be defined, but also has to be executed on, right? It has to be delivered in real time in that agent world that, as Sumit said this morning, never sleeps, right? So we combine multidimensional AI analytics and data to drive signal detection. Gary touched on that in the first part of the discussion. And leverage the power of Vantage to support real-time scalable signal processing. And then number 3, apply task-specific semantic data that's really defined through these data product definitions, right? To activate signals and really drive an agentic world around customer lifetime value, et cetera, these specific application domains, right? So the other thing is, this isn't just about financial services. We're starting in financial services, but it's applicable. I think it was telecommunications, right? Gary was one of the first areas that Gary first saw the opportunity to define these data products. So within our model library, there's actually a unified framework of shared, how a party, how an agreement, an account, how different events, transactions, et cetera, there's a base definition that transcends all the different models, right? And so it's like it says on the bullets, common modeling approach provides a natural linkage. There's different industries, but there's common patterns. We're not recreating the wheel, right? We're taking the same model, and a lot of the patterns we're going to do, it'll be different in telecommunications for customer lifetime value, but the pattern is very similar, right? So we're going to apply it across multiple industries is the main message here. The last thing and Steve McMillan mentioned this morning, is MCP agents, along with all the existing workloads that are on the warehouse, are just going to drive so much diversity, workload diversity in these environments, right? MCP agents are inherently chatty, and pun intended, pun kind of intended around a chatbot, et cetera, but it's very interactive, right? That's kind of what those little dashes mean on the MCP agent piece. At the same time, there's these massive workloads going on around chunking data, understanding, doing vector search, et cetera, within the platform, along with all the other workloads that's going on in the platform to prepare the data to do the normal BI and the reporting and whatever else is going on in the platform. Teradata just deals with it, right? The other part of this is a lot of this MCP agent workload. It's just another workload to the platform. It's not, it's an AI workload, I can't deal with it. From a platform perspective, it's just another workload that needs to be managed, right? And it can be operational. The key is it can be operationalized very quickly. So that is actually a really important thing, and using the core MPP capabilities of Teradata and scaling that is actually really important within this architecture. So to wrap up, right, the data products that we're doing, everything that we're doing is to drive this agentic AI future through that customer intelligence framework that's shown on the slide. But the advantages of Teradata on the top is really driving a lot of the capabilities. And one of those key advantages is our industry model definitions that we have that we're going to be applying to the data product definitions going forward, right? And we would love to work with customers in your environments to drive out and use our reference models as a template. I'm going to Dallas next week to talk to a financial customer about doing just that, right? So we would love to work with you and your teams to kind of get a jump start on the AI-ready data needed to feed your agentic AI future within financial services or any other industry for that matter. And with that, I think I'm done. Thank you.
Thank you, Gary and Bob. Much appreciated. We've got a couple of minutes for questions. If you've got a question, put your hand up and I'll bring the mic over so that everyone can hear. I might kick things off. A couple of years ago, we all got introduced to this data product concept from Degani and ThoughtWorks. It had a set of principles, but was pretty, not much else, not much more than that, right? Pretty well undefined. So how have you seen sort of the concept of a data product evolve in the market over the last few years? Should we be thinking about a data product as a single table or an entire data model or somewhere in between?
Some would look at it as a flattened data structure, right? From an analytic perspective. But the data product, again, actually I think I don't want to just say because of AI, but I am kind of saying that the definitional requirement around data product has gotten tighter, right? More broader, more important, right? And so we've had the data mesh for years and data product, right? But this will bring those data products to life, right? It's not just, and how the data product will have to evolve in a way to match the needs of agentic processing, and then there's an understanding how that's executing within the environment. It actually is going to change how data products and the life cycle of data products going to proceed within these environments, right? So the thinking of it as a data product is very useful, right? How that's going to transcend into the agentic world is going to be really fun to watch. And I think we're actually going to have some agents kind of watching, kind of like a modern model ops, watching what's going on so the data products can actually be adapted to what's actually happening, right? And be responsive.
Excellent, thank you. Any other questions?
Oh, there you go. You get the next one.
Thank you, sir. Thank you.
Yeah,
for-
hi.
Hey there.
So Intikhab from Ooredoo, Qatar.
Okay.
We are a telecom company. We've been using the the communications data model,
Okay.
but we used it initially. Then until version 14, we used it, and then we stopped using it.
Right.
But
Typical.
14 is a good foundation.
Yeah.
It's a very good foundation. Okay. So my question is now, since we are moving to the agentic AI, so you will have your, let's say, CDM or CLDM,
Mhm.
and are you going to have a parallel data model which sits on top of CLDM that will be the primary feed for the agentic AI, or
It's going to be, it'll still be the CLDM. The issue, I don't know if this is where you're going, but part of the issue is your implementation is not necessarily the CDM, right?
Yeah.
Right? And so we're actually gonna, we've been talking about this internally, is those data definitions, there's a way we can map that data model definition back to the base tables that you're actually using in your environment.
Correct.
Right? And then you can draw that knowledge through, because you probably don't have as complete a definition of your data model, right, that you've implemented in DML or in DDL within your environment, right?
And another question would be, when we are talking about the data dictionary or the data catalog,
Yeah, the data.
we are primarily talking about the logical, from the logical model perspective.
Uh-huh.
But when you feed into agentic, you have to think about the physical model
That's correct.
perspective. Okay, so
Yeah.
how are we going to bridge that gap?
Well, that's what I was just referencing, actually. Do you have, like, in your environment, do you have a physical model? Like in Irwin, do you have? So we would use that as a basis to start doing mapping between our data products that we define in that industry back to what it is really in your model, in your physical design. You have to, right? You have to. But you can use, if you've got that model, that's great, and there's hopefully some definitions there, so we use that, and we can fill in gaps with our model and our data product definitions, right? But if some companies don't even have that, right? So all they have is DDL. We could use that. It's text, right? We could do some level of mapping even at that level, right? Yeah. It's all wonderful. If it's text, we can analyze it and see what it tells us, right?
Yeah.
Exactly. And then you just start iterating from there. Yeah, exactly.
Did we have one more question? No? All right. Well, please, everyone,
Thank you very much.
Gary
Yeah,
and
thank
Bob
you.
for a very informative session. Thank you.
Thank you.
Thank you.
Bob.